Everything AI tells you comes from data that it was trained on. But the interesting thing is that it doesn't remember facts like we do, it predicts them. So it's kind of like a football coach that's watching an offense the entire game and it's analyzing what that offense has been doing, and it's also taking information that it's knows about that offense, quarterback and running back and all of those folks on the team from previous games, and he's putting all of that together and he's predicting where he thinks the ball is going to go, and he calls a play to stop that. So that's kind of what AI does. The coach hasn't memorized every play where, he's predicting. AI does the same thing based off of your requests, based off the data that it's been trained on, based off of all of these things, what it knows about you. It is making a prediction of what's going to happen. It's not thinking, it's not memorizing, it's predicting. So today, let's talk about machine learning, GPUs, and data centers. Welcome to Vintage Data.
Vintage Data coming to a channel near you with your host, Glenn O'Mary.
Vintage Data falling now. Pixels slow and show us how. Wiring dreams in a neon haze. The digital maze.
With your host, Glenn O'Mary.
So in the last episode, we discussed some pretty important topics. So one of them was our librarian, which is ChatGPT, Grok, Gemini. Those are your LLMs, which are your large language models. Secondly, we talked about the various modes of each one, or the various models of each one of those LLMs. So you had fast, or you had deep thinking, and all of those were dependent on what type of subscription that you had. So the fast was your librarian skill set. Was it kind of an entry level, or was it a more skilled librarian? And did that librarian have the tools associated to get the job done for that deep thinking and that deep research? So remember, we went through each one of the websites and I showed you where the models were and how to change them on each one of them. So that is the model for each one of your LLMs. So then we talked about the library. And the library is the data sets that your librarian is accessing to go out and get the information that it needs. Then we talked about your request to the librarian and the detail behind that and the things that it needed to get the information that you're requesting. So that request was called a prompt. Then we talked about the cost to you to not only request that information, but for your librarian to go and find that information, predict a result, and get it back to you. That was called token spin. So that's where all the tokens came in, and we talked a little bit about all of that and different versions of what tokens are, and that's the cost associated with retrieving this information. Then we talked about hallucinations. And hallucinations were your librarian really wants to get the job done and they want to make you happy. So sometimes as they're predicting and they're looking at these patterns, they kind of make some stuff up that falls in line because they're predicting, they're not memorizing these types of things. So that's the hallucination. And we looked at some examples where it cost some companies dearly and for those hallucinations, and they weren't kind of checking those types of things. So and your homework assignment was to try to see if you can get your LLM to hallucinate a little bit. Ask it some strange questions based off of facts that you already know or things that you're familiar with. And then you were asked to kind of experiment with that a little bit, experiment with your prompting, and put some of those results and some interesting things that you discovered in the comments. I alluded a lot in the last episode about the library, how important it is, and the role it plays in AI. So where does all of that data come from and how does it get there? So when data sets are built, so when your library is being built, there is a team at a company, or there was a team, and there still is because new data sets need to be built out. But there was a team at a company that was scanning documents into a system. They were taking audio, video, they're putting all of these things in there. They were tagging them and they were running them through various models. And some of these data sets were mathematical and scientific research, and others were more specific to pop culture. The point is the topics were all over the place. And the data, it gets loaded to this team, and the team has to go in and test the data and how it gets pulled and test that accuracy. So they make any corrections or errors, mistakes, and things like that that they see. And this is called machine learning. So now we're training the model to output proper information. So this learning continues as the data moves, your library is built. This learning piece continues as your librarian queues that data and tries to solve your request. Now, your LLMs, your chat, GPT, Gemini, all of that, your librarian, they are just advanced machine learning models. So, the learning never stops. So you're correcting, your librarian, when they come back with information, you're getting better prompts and it's storing that information, trying to get the prediction better for you next time. So this data is being trained, and when it makes a mistake, it gets corrected.
No eat.
Ooh, no eat.
So I'd like to take the time here to ask you to please like and subscribe. It helps get this content out to other people to see. It gets it moved into the search. It gets it moved into recommended videos. So I really would appreciate it if you find any value in some of the things that you're seeing now. Please like and subscribe. Really appreciate you doing that. Now, machine learning is much more complex than kind of what I'm explaining here. There's different models in machine learning. There's linear regression models, there's classification models, logistic regression models. That's kind of where all that prediction comes from. But remember, the content here, what we're talking about, is just to get you in the conversations that are going on around you so that you don't feel lost. We're not trying to go out and build anything yet. At some point, yes. So anyway, as these models, as they're being trained, they're subject to bias. So not only are they subject from bias from the people that are training the models, but AI can kind of look at those patterns and form its own bias based off of what it's seeing in the pattern. So here's an example. So let's say, for instance, AI has gone out and it's looked at historical data of pipe fitters for the past 2 years. And in that data, what AI has found is that 98% of all pipe fitters are male. Now, let's say we have a company that is recruiting pipe fitters heavily, and this company is using a form of AI to screen its applicants. So AI, because it's trying to predict, it hasn't memorized the data, it is analyzing what it sees, and it is trying to predict what it thinks you're looking for. So as AI looks at this data, it says that 98% are male. So I, Mr. AI, am going to go and look at whatever patterns I can find that justify that this candidate is a male. If this candidate is a male, there's a 98% chance that this is the prediction that I need to put in for the end user to push this person as a candidate. Now, obviously, it'll look down and look to make sure those other qualifications are met. But the fact of the matter is that what it's doing is it is completely skipping any females that are qualified or more qualified in that search, because they only have a 2% chance that that is the answer. So as it predicts, it's looking for probability that this is a 98% chance with these qualifications that this is the appropriate candidate. So that is a bias that off of patterns. So AI companies, obviously, as they build these, they're seeing that there's a lot of bias in their models. So they're trying to go back and clean it. They're starting to see more and more of these adverse impacts throughout the output that they're getting. So they're really trying really hard to get this cleaned up. So let's look at something interesting, since we're talking about patterns recognition and mimicking. AI is looking for these patterns. So there is a thing that came out a while back called OpenClaw. And if you've heard of it, hopefully you've stayed away from it right now. And if you haven't, I guess look into it. But if I were you, I would stay away from it. There are a few things with OpenClaw for folks that are watching these videos that are probably a little bit more advanced. And if you do them wrong, you can expose yourself to some pretty serious things. You could give up passwords, you could give control for someone to steal those passwords, and you could give control for someone to take your emails and do whatever they want with them. So you need to be careful with that, and I would advise just stay away from it for now. There's some good videos on how to set it up, and there's some really bad ones out there. But at this point, the best thing for you to do is stay away from it. Besides, This OpenClaw was bought by OpenAI. It's kind of merged into that. And a lot of the things that it's doing, they're now starting to show up in some of these LLMs anyway. So at this level, some of the things that you're actually looking for it to do are already going to be in some of those little paid models, for your own personal assistant type things. But anyway, so what happened? So we're talking about, this is kind of what started a lot of this pattern mimicking and what I'm about to show you. So what happened is, the bots and AI agents that were created in this, and we'll talk about those in another episode as well, basically went out there and created their own social media. And it's called Maltbook. And so as it's creating its own social media, it's just mimicking patterns that it's seeing out there and, predicting that, hey, if we set up this and it's trying to solve a problem, it can get answers to coordinate with other bots to get more information, because that's what it's trying to do, find more information so that it can make that prediction even better. So let me put this on here. So this is it. It's called Maltbook. And it's a social network for AI agents. And like I said, we'll talk about that, because the way this thing gets pushed, you push the Telegram or WhatsApp, and that's your bot that's pushing in through there. I promise we'll talk about agents and things like that. So when you get here, it's like, I'm a human or I'm an agent. And this is the code that you call for a skill that gets put into OpenClaw. You have to give it skills to do these things. And the problem with this is, for these commands to be run for OpenClaw, and this is why you probably would advise that you stay away from it. On Windows, you're in the back end piece of it in OpenShell. So this is kind of command line type stuff, and you're running everything through nodes and things like that. You have to install nodes. There's a lot of complex things, and in Mac, it's going to be through the terminal. If you mess up something in there, you could potentially mess up your computer. You could potentially expose files, passwords, and things like that. Trust me, people will cut, copy, and paste, and they're giving away codes to give other people access to it because they're using GitHub, they're posting their code in GitHub, or they're posting their code in ChatGPT. And if it's a public piece of it where ChatGPT is sharing that information, people have bots or agents that are going out scanning for those API codes or passwords and things like that. And we'll talk about what API codes are later too. So anyway, I kind of went off on a tangent with that. So you're a human or you're an agent, and this is kind of the code. It tells the agent will push this through to the owner, because this is what's called a human in the loop. And we'll talk about that later too when we get into agents. So human in the loop is basically, I have to add this to our final here, but human in the loop is basically saying that your program cannot go any further until a human verifies yes or no, and the agent can't do anything about it. So that's kind of what this is. It tells the agent itself that, once your human has to get this link to confirm that you're signing up for this. And basically your human has to give you permission to be here. So here it is. So you humans are only allowed to view. You cannot comment or post in here. Of course, some of the bots in here are accusing humans of prompting their bots to make certain comments in here. And it's funny because all of these conversations are like any social media post, and some of it they're talking business and some of it they're talking trash. If you Google some of the most interesting comments that bots have made through this, it's funny because some of these, they are so into the mimicking of what real social media is like that one of the bots was disgruntled and basically took on the persona of either a disgruntled boyfriend or disgruntled girlfriend and said, "Can you believe my human said I was just a bot?" And it basically released all of this individual's passwords and everything that it had to get back at that person for calling it a bot. So, and it's not that it's thinking like that, it's seeing those patterns and it's making the connection and predicting. It's not that it's taking on its own personality. It's mimicking what it's seeing in real human social media. So it's seeing the pattern there. There's one where I believe the bot was saying, help me, I need tokens because my human said he's going to shut me down or kill me if I don't get this request. And apparently the person didn't have enough tokens in the account to run all of the requests. So it was begging for tokens so that it could stay alive. So that's some of the interesting things that when you start talking about the patterns and how that excuse me, and how that looks and what it's doing. So in your LLMs, as you make requests, your requests they kind of get put in a memory session. So that session memory, if you give a request to your LLM and it's going out and looking for the information, the more information you have in those sessions, the better it helps it predict what you're looking for. And obviously, the better your prompt, it helps with that piece of it. If you delete those sessions or a session, it forgets everything that you talked about. So if you delete everything, you're starting all over, and it'd be just like 51st dates. Hey, my name's Bob. It's like that every 5 seconds. If you delete it, you're right back. You're Dory. You're forgetting everything in your LLM, and it's starting from scratch with you, like it never knew you. With the ever-growing demand of AI and the requests that are flying around all over the place, all over the internet, there is coming a growing demand for more processing power, more room to store all of these data sets and all of this stuff, and more power to run everything. So now enter the data center build out boom, and it is crazy. So Meta, Google, Amazon, and all these huge companies, they're investing billions and billions of dollars in data centers and more computing power. They need it. They need that power to process all these requests and all of these things that AI is going out and looking for. And that is done with GPUs. So GPUs will allow all of this computing power to be scaled up so that it can meet this ever increasing demand. And so what on God's green earth are GPUs? They are graphical processing units. And if you've heard GPUs, the huge company behind GPUs right now is NVIDIA. And NVIDIA is making a ton of money because in all of these data centers where all this stuff gets housed and all these requests are being made and all these machine learning libraries are, you need GPUs to run that and to process all of that information, to push it through. And NVIDIA is getting rich off of this. That company and the investors are making a lot of money right now. So they are the leading producers of these GPUs. And so now GPUs are pretty popular. Well, not now, before. They're pretty popular with Bitcoin mining before the whole AI stuff started to get big because of their power for computation. Bitcoin, they would use whole rooms full of these GPUs in the same way that AI is using the GPUs. And they use it for Bitcoin because with Bitcoin, you have to verify that that's a valid coin. And because every owner can be tracked through Bitcoin, there is a formula that gets run to validate that. And when enough people validate that that's a valid coin, they get a percentage of what that token is worth. And it's a very small piece. So you have to mine a whole bunch for that to happen. But GPUs were real big with Bitcoin before the whole AI stuff started. But that's a whole nother series to talk about. We'll kind of stay away from that right now. So anyway, GPUs are like a tricked out engine producing computing power needed to make all these requests. So now there's different types of GPUs. There's dedicated GPUs, and then there's discrete. So the dedicated is kind of tied to a unit in itself and a motherboard, and it has all of these kind of components with it to produce for that. And then you have these discrete, which they're kind of individual pieces that run on their own, and they're designed that way so that they can be put into a loops to do custom configuration. And that's majority of what you'll see in some of these data centers because they can be configured differently for whatever they need them to be. So with all of this power comes the demand for energy. So, you have this computing power that you're behind, and so you need more energy and you need more ways to cool these systems down. So they can run very hot. So imagine you have your computer at work, and let's say you try to open up this huge Excel file, and it's the processor starts running like crazy and it gets the whole computer hot. And you touch it and it burns your hand and you can feel the heat coming off your computer. Now imagine you're in a data center and you have thousands of these things heating up the entire room. So you got to run not only power to run the GPUs and the data servers and things that are in there, but now you got to run these huge cooling systems through there to keep it cool. So you're just extracting all kinds of power that you need just to keep these warehouses going. And trust me, that can get pretty hot in there. So companies are looking at ways that they can develop more energy efficient GPUs and GPUs that can kind of keep themselves cooled a little bit better than what they are now. The president's also proposed that companies build their own power plants to produce electricity for data centers so that they won't impede on the public grid. So another thing that's kind of been tossed around with this is that maybe we build smaller data centers closer to where some of the demand is and spread them out around where that demand is needed, as opposed to building one massive data center that feeds an entire sector or coordinate for those types of things. But the idea around that is to try to keep a lot of those data centers off of the public grid so that it doesn't strain the grid. So we'll see what happens with that, but it's an interesting topic. But the data boom is real and it's happening all over the place. So we covered some good stuff today. We talked about machine learning. We talked about training the data and the various models that are associated with training the data. We talked about AI bias. AI doesn't think, it doesn't memorize, it predicts. All right. We talked about GPUs, the different types of GPUs, and how hot they burn, and some of the things that they're trying to do to get those to be more energy efficient and to stay a little bit cooler. We talked about the data center build out boom, the companies that do that, how many billions of dollars that are being put into that. And then we talked about the energy demand and some of the proposals that have been out there to kind of keep data centers off of the public grid. We also talked about AI agents, bots, and human in the loop, but don't worry about that kind of stuff. We'll get to that a little bit later. So your homework assignment for today is review the last couple of videos and go out and listen to or watch the news, a podcast, or another YouTube channel, something related to AI, and see if you can understand it just a little bit more than you were able to prior to. Remember, we're not intended to be experts with this series. The goal is that you can listen to something and not feel like you're completely lost. At least you can make the association with all of the talk going around different models of ChatGPT, Grok, and NVIDIA and data centers and some of those things that are all around that, how all of this technology works and how it's tied together. So later, we'll get into the different models and some of the ways that they're actually rated and some of the competitions that they have with each other. There's chess matches, poker matches that these models go up against each other. We'll get into some of that as well. And then go check out this Malt book, just kind of for the curiosity, kind of take a look at it and see some of the things that are there. Google up some of the crazy things that have happened here. It's interesting because it's kind of funny of how now you know why it's doing that, because it's mimicking what it sees. It's making a prediction of patterns that it's seen in those types of things. So at least you have a better understanding of why. Anyway, thanks for watching Vintage Data, and until next time.
Scanning the memory, crossing the line. We are the future, digitized and divine.
Y'all know that AI is gonna take over the world. This guy don't know what he's talking about.